Hey guys, and welcome back to my channel. Today we're going to build a simple face detection library using OpenCV and Python. So OpenCV, or Open Computer Vision, is a really good library for beginners to get computer vision in their toolset. In this video, we are not only going to program a simple script, but we will structure it in a class so you can import it into your other projects and use it with just 3 lines of code. So let's get started. The first thing we need to do is create a virtual environment. So I'm going to be using Python 3, so I added the -p tag to specify that it's a Python 3 virtual environment. I'm just going to name it env. Now we just need to activate the environment, and then we're going to install OpenCV Python. And we're just going to wait for that to finish. Now, before we begin programming, there are still 2 more files that we need, and it's the haarcascade files for the face and for the eye. I'm going to put the links to both those files in the description, but I'm going to download them right now to my computer. Okay, great. We have all our resources. So let's code. The first thing we want to do is we're going to import the OpenCV library. Next, we're going to create a class camera, and that's going to hold all of our camera functionality. Like I said in the beginning of this video, we're not just going to create a script that's going to run through and do only one thing. We're going to create an actual library and a class so that we can import this into other projects. So the first thing is we need to actually capture video. So we're going to do that right now. Next, we're going to set up 2 flags, face detection and eye detection. We use these flags because if we want to turn on our face and eye detection in different libraries, we could do that without actually having to rewrite the code. All we have to do is just tag it saying detect eyes or detect face. So before we begin actually getting the video from the camera, we're actually going to set up where to get the cascades from and actually detect our faces and eyes in the video. Right above the init function, we're just going to create a dictionary called cascades. So we have the face and the eye cascades. I saved my cascade files in the same directory as the actual script, so I'm just going to go ahead and write this in cv2.cascade classifier, and then I'm going to do the same for the eye, and then I'm going to tell it where to find the actual cascade files. So like I said, the cascade files are in the same directory as the script, so we're just going to actually write out the name of the cascade files. So I have the haarcascade eye.xml, and I have the frontal face default.xml. Now OpenCV does have a few different cascade files for cat faces, frontal and profile faces, full body, torso. So with the way that I set up the cascade dictionary, you can actually just add those in and then detect those without having to completely restructure your code. So next function we want to create is a get frame function. And this is just going to be a quick function that's going to just pull 1 frame at a time from the camera. So when it comes to using the cascade files, they read images that are in grayscale, and that's what we're going to do next. We're going to create a function that's going to take a frame that we pass to it, and we're going to convert that into a grayscale frame. So that's going to be def grayscale. So, and then we're going to also add a variable frame. So we're going to do gray equals cv2.cvt color frame. It's going to be cv2.color underscore bgr2 gray. Now it's important to note that when working with OpenCV, we're used to hearing the term RGB, red, green, blue in that order, but OpenCV actually operates in blue, green, red. Next, we're just going to return that grayscale frame. And now we're going to create a one-line function that is going to just display our frame whenever we ask it to. So it's going to be definition display self add the frame. Then we're going to say cv2.imshow or image show. Going to tag it as image comma frame. And all that's going to do is it's going to create a pop-up box that's going to display what our camera is currently seeing. Okay, so right now what we have is we have an initialized function that's going to find our camera. We have two flags that we're going to ask whether or not we want to do facial detection or eye detection. We have a get frame function that's going to get the current frame from the camera. A grayscale function that's going to turn that frame into a grayscale frame. And we also have a display function that's going to display any frame we pass to it. So what's next? To actually detect faces and eyes. So we are going to start with the definition detect face. We're going to pass the frame to this detect face function. So we're going to need to convert this frame into a grayscale frame in order to detect faces. So we're going to do that now. We're going to say gray equals self.grayscale. And then we're going to pass the frame. And what we're going to get returned is this function. It's going to return the actual grayscale frame. Now, how do we find the faces? So we're going to create a variable called faces. We're going to use the face cascade classifier that we defined up here. So there's going to be self.cascades. We're going to find the face in a dictionary. Then we're going to say detect multiscale. We're going to pass it the grayscale frame. So what's happening here? What we're doing is we're using the cascade classifier to detect faces within that frame, and what we're going to get returned is a list. So right now we're going to iterate through that list to find any faces in frame, and then we're going to draw a square around the face. So for X, Y, W, H, so the XY location of the face and the width and height of the face in the frame. In faces. So we're going to draw a red square around the faces that it detects. So the way we do that is we're going to call another cv2 function, cv2.rectangle. We're going to pass it the frame. We're going to pass it the XY location of the face that we're currently iterating on. And we're going to tell it the size to draw. So it's going to be X plus width and Y plus H. So what we're doing here is we're telling it the actual width to draw around the face. When we draw a rectangle starting from the bottom left, we do X plus the width to get fully across, so X plus the width, and Y starts at the bottom, so it's gonna be Y plus the height, and that's how you're gonna get the full rectangle around the face. We're gonna pass it to RGB for red, which is 00255, and that's gonna give us red. And then we're gonna pass it the line thickness, which is 2 pixels across. Okay, so now that we have the face, we're going to want to detect the eyes as well. And in order to detect the eyes, we need to have the face. So while we're inside this face loop and we've already classified where the face is at, we're going to look in just that area of the frame in order to find the eyes. So what we're going to do is we're going to create a gray section and a colored section. So gray section equals, so we're going to use the gray frame. And we're going to say Y plus H, and X plus W. And then we're going to put in the color section. So when we pass frame here, the frame is our colored frame, and we have gray, which is the grayscale frame. So now we want to get the color section. So instead of using gray, we're going to use frame. We can just copy and paste what we have here. Okay, so now that we have the colored section and the gray section, we want to detect the eyes, but we don't have an eye detection function yet. So before we move forward with completing the face detection function, we are going to come right above detect face, and we're going to create a function, detect eye. Self, and we're going to pass it a gray frame and a color frame. So same as what we did with the faces, using the Cascade classifier to find our face in the frame, we're going to do the same for the eye. So we're going to say eyes equals self.cascades eye dot detect multiscale, and then we're going to pass it the gray frame, and just like faces, it returns a list, so we're going to iterate over that list. So for, and again, it's going to be x, y, width, and height in eyes. So we're going to iterate over every eye that we find inside this one face, which would be 2 maximum. We're going to draw a rectangle over where we find the eye. So it's going to be cv2.rectangle. So the reason why I passed the gray frame and the color frame in this one function is because I use the gray frame to detect where the eye is on the face, but I need to draw on the colored frame, which is this one. So we need to know where in the frame to draw, and that's why we pass the color frame. So when we do cv2.rectangle, we're going to use the color frame to draw. And again, like with the cv2 rectangle for the face, we're going to pass it the xy location, and also tell it how big to draw the rectangle around the eyes. It's going to be x plus width and y plus height. In this case, I'm going to draw white boxes around my eyes so it can stand out a little bit more in the frame. So we are going to do that by passing the RGB white, which is 255, 255, 255, and we're going to do a line thickness of 1. Okay, there we go. Now we can detect eyes in our frame, and we can detect faces. So to finish off this detect face function, we're going to say if self.eye detection is true, self.detect eye, and we're going to pass it the gray section and the color section. And that's going to detect the eyes for us and draw it on frame. Okay, so we have 2 more functions to write. So we're going to write the detect function, which is going to see if we even want to detect our face, and then detect the eyes if we want to detect our face and the eyes. And then we're also going to write a run function, which is going to start this program for us. So let's go right below display, and we're going to write def detect self frame, and we're going to write if self.face detection is true, self.detect face, and then we're going to pass it the frame. Now, the reason why I set this up this way is because I want you guys to be able to add any more cascades that you want, and then add it right into this detect function. Add another elif clause or just an if clause if you'd like, and then you'd be able to build on top of this and put it into your own code without having to actually rewrite the code. Okay, so now we're going to write the run function. We're going to say def run self. So while we're here, we're going to say while true. What we're going to do first is we're going to need to get the frame. So we're going to get the new frame, which is equal to self.getFrame. So once you have the new frame, we're going to say self.detect with the new frame. And because I want to show you guys what it looks like, we're going to say self.display also with the new frame. And the reason we do the detection before the display is because we want the boxes to be drawn before we display the frame. And now we're also going to add a wait key, so that way we can press the escape function and kill this, because we're in a while loop. So if we don't have this, it's going to keep running and running until we kill it through the command line. So we're going to say k equals cv2.wait key 30, and then if key equals 27, we can break. And 27 is the escape key. So now that we have our run function, we have to do a little bit of cleanup with OpenCV. So after the while clause is completely finished, we're going to say self.cap.release. So we're going to be releasing the camera from our program, so that way the computer knows we're done with it. And then we're going to say cv2.destroy all windows. So that's going to destroy any open CV2 windows that we have that's displaying any frames. So we have a completed class here. So let's just go through it again. We have the class camera, we define our cascades, we have the initialized function that's going to get our camera for us and set our flags. We have our get frame function to get the frame from the camera, grayscale to convert that frame to a grayscale frame. We have the display to display the frame on our screen. We have the detect to see if we want to detect our face, and then if we want to detect our face with the detect face function, we can detect our eyes if that's also true with the detect eye function. Then we have the run function, which will just run a loop for us and continue running this program until we stop it. So let's try this out. If name is equal to main, we're going to create a class, new camera equals camera. So if you remember, we have both our face detection and our eye detection equal to false. So if we run this right now, it's not going to detect our face or eye. So let's just say new camera dot face detection equals true. Oops, just equals. And then new camera dot run. Now we're going to clear my terminal, and with any luck, there shouldn't be any errors. I'm going to say, as you can see, I'm still running in the virtual environment that we created. So we're going to say Python. I named my script face detection. And if I run this right now, we should only be drawing our face and not our eyes. Okay, what did I do wrong here? If key is equal to 27. Okay, yes, so I put K here, and then I also wrote key because K is the key, and that was just a slip on my part. So let's just fix that, and let's run it again. And as you can see, it's drawing a square on my face, a red square as we indicated. All right, so it looks like we did good. Press escape, it cancels. So let's also come back and say new camera dot eye detection equals true. And now we should go ahead and see our eyes being drawn in the frame. There we go. All right, so there you have it. We have created a class camera, and you can see we are able to just go ahead and run this entire function with just a few lines of code. We have the face detection, eye detection, camera class, and run. And that's all you need in order to import it into any of your working programs and just get started with computer vision. Well, I hope you enjoyed this video. Please hit the like button and don't forget to subscribe, and I'll see you in the next one.